finally going to start working on solving equations or compound inequalities. That's what I meant. And now if we want to work with compound inequalities, there are again three different types that we have been working with. The first type is a three-part inequality. The second one being the inequalities connected by and last one being compound inequalities connected by or. We might be a little bit more familiar with the last two types of compound inequalities because they come as more of a combination that we can directly see from what we learned before about individual linear inequalities. So we're going to start from the three-part inequality just to get that out of the way over here. And remember, we said this is called three-part inequality because we have the variable and all these things in between and the restrictions on either end. For this type of inequality, we are saying that we really just have two restrictions on either side of the variable that we get. And to solve this type of inequality, we're really treating it very similarly to how we did with regular inequalities that we had worked with before. But instead of doing everything the same way on both sides of the inequality, we're thinking whatever we do to one part of the inequality, we have to do it to the other two parts of the inequality as well. And at the end of the day, the goal for us to solve an inequality is to get the variable by itself. So our goal is still to isolate the variable. So to isolate the variable here, we notice that x is in the middle, and right now it's with the term 20 in front of negative x over here. So the first thing we're going to do is again get rid of the constant term, just as we would when we had linear inequalities before. So I'm going to start with subtracting 20 on every part of this inequality. So we would get negative 7 minus 20, that's less than 20 minus 20 minus x, and this is also less than or equal to negative 2 minus 20. So if you look at it, the difference between what I did versus the original inequality is that I just subtracted 20 on every part of my three parts over here. And the inequality symbols are what separates the parts. Just like before, the inequality symbols separate the two sides. Here it separates things into three parts. And before we go any further, we want to go ahead and simplify things on each part of the inequality as much as possible before we move along. So negative 7 minus 20 would be negative 27. Less than here, 20 minus 20 in the middle cancel each other out. I'm left with negative x. Less than or equal to negative 2 minus 20 gives us negative 22 over here. And that's what we need to do. Now I only have the variable x with a negative sign in front of it. And just as before, if we have a negative sign, in order to get rid of it, we need to divide by negative 1, or you can think about multiply by negative 1 in this case. So if I go ahead and divide it by negative 1 over here to get rid of the negative sign in the middle, I have to do it to the other parts as well. And as we do it, negative 27 divided by negative 1 gives us 27 over here. And just as any inequality we worked with before, anytime you multiply or divide a negative value, you have to switch the direction of the inequality symbol. So then less than becomes greater than. And negative sign cancels out in the middle. And again, the less than or equal sign flips to be greater than or equal to 22 over here. And now we have a result for our compound inequality that was a three-part inequality. If we want to write everything in formal notation, we can again start from any of the notation that you feel comfortable with. If we start with a number line notation here, I'm going to go ahead and draw the number line. The cutoff value or restrictions I have are 22 and 27 over here. And in this case, I can include 22 and anything that's greater than or equal to 22. So here with a flip of the inequality symbol, things might look a little bit confusing in terms of which one's larger, so make sure you keep track of things a little bit. Here we have x is greater than or equal to 22. So we need 22 to be the left side boundary, and we also know x is less than 27, or 27 is greater than x over here, without including 27. So we need this part to be the result of our number line notation. And then for our set notation, we can write it as x such that I like to write from smaller values to larger values just because that's going to be the order we see in interval notation anyways. So I'm going to kind of flip everything around to have 22 less than or equal to x less than 27 as my set notation. And lastly, for the interval notation, remember our left side is included, that left endpoint is included, and going all the way to 27, which was excluded as part of the solution. So that's how we write the final answer in different notations, and more importantly, that's the process we take in order to work with a three-part inequality. The principle is identical to what we did with linear inequalities before. The only difference is that now we have three parts, so whatever you do to one part, you have to deal with the other two parts, so they're all consistent throughout. Now with this in mind, if we want to work with part B, this looks a lot more similar to what we worked with before. We have two linear inequalities, and what we're going to do is essentially simplify or solve them as much as possible before we combine the results using the word and. And we understand from before, when we have the connecting word being and, we are looking for the overlapping part, the intersection of the two inequalities. And here, if we look at the first inequality, I'm just going to copy this down really quick. This is the first inequality we're working with, and to solve it, we are isolating the variable again by subtracting 10 on both sides first, so we can get the variable term by itself. And this is less than or equal to negative 17 minus 10 over here. And here on the left side, we're left with just a variable term, 16x, less than or equal to negative 27. And now for the last part, we're going to go ahead and divide 16 on both sides to get x by itself. So here we're left with x is less than or equal to negative 27 over 16. It's not a nice number, but that's perfectly fine. We're cool with working fractions in general. Now for the next part, for the other inequality, we got 5x minus 1 is less than 3. Same thing as before, we can go ahead and add 1 on both sides to get 5x by itself. And with a cancellation, we're left with 5x on the left, less than 4. To get x by itself, we can go ahead and divide by 5 on both sides, which results in x is less than 4 over 5. We didn't have to deal with switching the direction of the inequalities at all, so we know that we can just go ahead and keep the direction because we're not dividing or multiplying negative values at all. Now if we want to combine the results connected by and, remember when we have that and, we're looking for where the two intervals would overlap with each other. If it helps, you can again do a sketch of the number line as we did before. And here we have x is less than or equal to negative 27 over 16. And we can just tell it's going to be a smaller value because it's negative. And 4 over 5 is going to be the larger value because it's a positive number. That's really the extent of information you need. You don't need to use a calculator to find the exact value in this case. And if we want to look at the part that's less than or equal to the negative number and also less than the positive number, here we want to look for the overlap, which again gives us this part over here. And with the notations we have we can write the number line notation first if you want. And we would get just the part that's below negative 27 over 16. Now for set notation, we can use a similar format. X is less than or equal to negative 27 over 16. And lastly, for infinity, because there's no boundary on the left, all the way to negative over 16, inclusive. And that's how we use different notations when we have that and be in the connecting word of two inequalities over here. Have the situation where it's connected by or. So same thing as before, I'm going to solve the two inequalities separately first and then combine the results at the end. So I'm just going to copy down the inequalities first. That way I can keep things organized. And the first one, if we want to get x by itself, we're going to go ahead and subtract 4 on both sides of the inequality over here. So we get negative 3x plus 4. To cancel that out, we have minus 4 less than or equal to 7 minus 4 over here. And once we do the cancellation, we get negative 3x is less than or equal to 3. And to get x by itself, we have to divide negative 3 on both sides. Once that happens, we know we're working with division or multiplication of a negative number, so we gotta flip the inequality symbol to be greater than or equal to negative 1. Now similarly, on the other inequality, we would have negative 1/2 x minus 5. We can add 5 on both sides just to get the variable term by itself. And once we do that, we're going to get negative 1/2 x is greater than or equal to 11. Same thing as before, we could divide by negative 1/2 on both sides to get x by itself, or you can think about multiply by its reciprocal. So we can multiply negative 2 on both sides of the inequality. Here we would get x as a result of the cancellation and negative 22 on the other side. Same thing as before, we're multiplying a negative value, so we get to flip the inequality symbol. So we get x is less than or equal to negative 2 over here. And now, to conclude this part, we are having the connect word of or, so that means anything that's covered by at least one interval, we just want to include that as part of the answer. So as a result, we get x over here, and x is less than or equal to negative 1, which would be over here. Or alternatively, we can have, I should probably scale it a little better over here. We would have x is greater than or equal to negative 1, which is actually on the other direction. And then we also have x is less than or equal to negative 22. So both are inclusive of the endpoints. That's the end result we have if we include both intervals on the number line. And because we have an or statement, we just want to look for the part that's covered at all. And as a result, we can see we're just putting a combination of the two. If you want to use a set notation first, we can have x such that x is less than or equal to negative 22, or x is greater than or equal to negative 1. That would be the notation we use. We pretty much just state the results over here. And now for the number line notation, we're pretty much just copying down what we got over here. So I'm just going to go ahead and bring this whole thing down here instead of drawing this all again. And lastly, we can write the interval notation. In interval notation, we said before, if we have multiple intervals to include, we gotta use a union symbol to write that. And the first interval is going from negative infinity to negative 22, and it's a union. It looks like a U shape. And for negative 22, it should have been a bracket. And for the second interval, we have negative 1 all the way to infinity over here. And that's how we write the interval notation for the final answer connected by OR. And that's how we work with all three types of compound inequalities. Take a minute to make sure you fully understand the process for different situations before you move on to now you try problems.